So, going over the vocabulary for Unit 3, we'll start with scatterplot, a term we know. Scatterplot looks like this. But I asked you, if we can interpret the scatterplot, which of these you think has a correlation or maybe a association? The one on the left, right? I see more of a trend here than I do here. This is all seems kind of random. Like if I'm interpreting how this variable affects this variable, it doesn't, seems like it doesn't, right? It's just random. Could be temperature, whatever, I don't know. But here, this variable seems to affect the height. So as I increase, what happens to my height? It looks like it also increases, like so. So we'll be dealing with scatter plots this entire unit. Now, a very important term, association. It's a deliberately vague term describing the relationship between two variables. It's not to be confused with a correlation, which is a precise term that measures the relationship. So I see that there may be an association here, but I haven't done data and calculations to actually prove that there's a correlation. Does that make sense? I can see association, but I can't prove it yet, which is a correlation. So when you're talking, most people accidentally say correlation, but what they really mean is association. Because most people don't exactly have the data with them to prove what they're trying to make a point of. Regression line, line of best fit. So we're going to take this data, this association that we see, and actually find a correlation. It's a line that best fits the data. Each predicted y tends to be closer to its mean than its corresponding x. And what that means is, this is basically the average. This is basically your mean. Notice how this line represents more of the average than the actual point of this x. This line, so I can see how this point, is a little bit more towards the mean than this one, right? Because it's closer to the regression line. This point is farther from the mean than this point. Does that make sense? So this kind of represents your mean of your data, like so. Again, this is an Algebra 2 term. And we'll see how to calculate this line. Now we have both a response variable and an explanatory variable. So we have our equation. That's what we're going to use to find our regression line is going to be an equation in the form of y equals. Now it makes sense that this is the response variable because based on the data I input, I get a response, right? Response variables are usually going to be on the y, so in this case your vertical axis. And the explanatory variables are the x, the predictor variable. Like the main power of regression line is predicting future values. Say I'm given this data, which goes in temperature, but what about 30 degrees Celsius? What happens here? I don't have that data, but I can predict that information as I extend this line. So the predictor variable is what happens at 40. Well, I think at 40, it's going to be about 20 firefighters, based on whatever this is saying. So explanatory variable is what you're calculating, and then your answer or your response is the y. Correlation coefficient, measure how strong a relationship is between two variables. So this is when you actually have the data to prove something affects something else. So notice how, would you say number 1 has a stronger correlation than number 3 over here? And a lot stronger correlation than number 4? So notice how these data points are a lot closer to my regression line than say this one. So this is how we're going to kind of interpret it. This is a large positive correlation. So it's going to the right. When we find slope, we'll see all values are going in a positive direction, up, positive, over, up, over. This will be a negative correlation because we have one variable that's going to this negative direction. If I go up positive, then I have to go left, negative. If I go down, negative, then I have to go positive. This will be a medium, a small negative correlation, and of course, when you see something like this, you would say there's no correlation. Again, notice the difference between association I have no line of best fit, right? I can kind of see it. I could think maybe it's medium. But when I actually calculate the regression line, I can see, yes, there is actually a correlation. And again, there's even more stuff to give you numbers later that actually proves that, instead of just looking at the graph. A special notice, like I was saying, scatterplastic correlation coefficients never prove causation. That's one reason it took so long for the U.S. Surgeon General to put warning labels on cigarettes. Although there was plenty of evidence that increased smoking was associated with increased levels of lung cancer, it took years to prove evidence that it actually causes lung cancer. So, just because you're in this class and when you're done with this class doesn't mean you're proving anything. We're actually talking about associated. Lurking variable, a hidden variable that stands behind a relationship and determines it by simultaneously affecting the other two variables. Now, what do I mean? So, did you know that ice cream sales and shark attacks are correlated? If you get the increased sales of ice cream, actually increase shark attacks. Now, there's a lurking variable, and what do you think that is? The weather, temperature, right? If it's sunny, you're going to be eating ice cream. If it's sunny, you're going to be out in the ocean with shark attacks. Also, number of volunteers. The increased number of volunteers affect the increased damage of your home, like hurricanes. So the more volunteers you have helping you build your home actually affects the damage that your home. Well, what's the lurker variable there? That doesn't seem like it's going to be associated. Well, size of the natural disaster. The bigger the hurricane, the more volunteers you need, the larger the damage, right? One more, you decide. Does sunscreen sales increase skin cancer? Does the largest number of sales, as sunscreen sales increase, so does skin cancer? What's missing there? What would be the lurker variable? What's that?
Because you're out in the sun.
Yeah, out in the sun. So in the summertime, we're going to have this increase. Likewise, skin cancer is going to increase. So yeah, it would be the weather or the season. Predicted value are calculated from the regression line equation, and residuals is how far that model's prediction is from that point. So I have my actual value here. I have my regression line. My predicted value is going to be on that same x, but I'm looking at the y value. So in this case, my predicted value based on this regression line is about, I guess, negative 4.5, 4.6. The actual measured value was a 5.7, so that residual is the difference between the two. How far was that point from your regression line? Here, this had a lot better predictive value, right, compared to the measured value, smaller distance. So this residual value would be a lot smaller than this one. This is going to help us find outliers with scatter plots. And then one more, regression to the mean. You hear this a lot with sports. All of a sudden somebody's batting a 500. That doesn't make too much sense. Eventually they'll start regressing more to their actual average of 0.25 or whatever. So it's something that varies normally between two far extremes. It usually swings back normally, naturally, and two values in between. So you can kind of see this a lot with stocks. Notice there was an increased stock here, a peak, and then there's a drastic decrease, and then notice increase, decrease, but it kind of has a normal trend to it, right? Even though it's way back here, it dropped way down here, it's slowly going to go down here. Kind of like when you're flipping quarters. Say you had 6 heads in a row. Well, eventually, the more you flip, it's going to average to a 50-50, right? Probability. Maybe you have 16 tails in a row. Eventually, it's going to average up. That's regression to the mean.